Algebra 2, Unit 3, Lesson 2, Solving Inequalities. So now we want to solve one-variable linear inequalities. An inequality is one that will either be either a less than, a bigger than, a less than or equal to, or the bigger than or equal sign into it. And there are two differences between that and equations, otherwise they're the same. Inequalities are transitive, but they're not reflexive or symmetric. So A less than A is not true. A less than B does not mean B is less than A. In fact, you have to reverse the sign. It means B is bigger than A. So when you switch the sides, you have to also switch signs if you're going to do that. But if A is less than B and B is less than C, then it will be true that A is less than C, so less than is transitive. So keep that in mind, especially for this one, is the one we're mostly going to use. If you want to switch the left and right sides, you also have to switch the sign. And then the other one is if you multiply or divide by a negative, you have to reverse the sign to get an equivalent inequality. And let's consider why that's true. Suppose you start off with 2 is less than 5. If you multiply by -4, and you would get -8 and -20. So which one's smaller? Is the -20 is really smaller. This would no longer be true. We have to switch the inequality sign in order for that to be true. And that's because when we multiply, we make a bigger negative, but the bigger negative is actually really smaller. And then we're going to graph solutions to inequalities or number lines. I'll remind you that if there's an equal that's included, either less than or equal to or bigger than or equal to, the endpoint is a solution, and we're going to fill in the circle for that endpoint. If the equal is not included, meaning we have less than or bigger than, the endpoint is not a solution, and we're going to use an open circle. And then we're either going to shade to the left or to the right. Left then, of course, means we want the numbers less than that number. To the right means we want the numbers bigger than that number. If we're solving and we get an equation that's never true, like 0 is less than -3, then that means the inequality has no solution and our number line would have nothing shaded. If we're solving it and we get a statement that's always true, such as 2 is less than 3, then every real number is a solution, and we would graph the entire number line. So let's start off. We're going to divide both sides by -7. You may not write it as part of the same equation if you're going to write. If you write it, you have to make sure you reverse the sign. If you go from here to here and you actually do the division, you wouldn't have to write it. So if you're going to show that you're dividing by -5, make sure you rewrite that and put a bigger than sign. If you just fix this up, I will count it wrong. So now k is more than -9. So this means we want all the numbers that are bigger than -9. I would like you to put it one number bigger than the number you're given, one number smaller. So we have -8 and -10. The -9 is not included because there's no equal, so we put an open circle, and then we want all the numbers bigger than that. That's to the right. In the second one, we have 8a minus 15 is bigger than or equal to 73, so you would add 15 to both sides. 8a is bigger than or equal to 88. Divide both sides by 8. You get a is bigger than or equal to 11. Here you have 11, one smaller, one bigger. Again, it's closed circle now because there's an equal there. You want bigger than, that's everything to the right. Here we have 9x plus 2 is bigger than 9 times x minus 3. If you divide both sides by 9, you would get x plus 2 is bigger than x minus 3. If you then subtract x from both sides, you'll get 2 bigger than -3. That's something which is always true, and therefore all reals are solutions to it. If you showed in the number line, that's everything. Now we're also going to take word problems and turn those into inequalities. We have to understand different English expressions which give the various inequalities. So equal comes from is or equals or is the same or identical to. This is less than or fewer than. The two that are the hardest are these. They have at most and at least. At most is really less than or equal to. If I tell you you can be at most 12 to go into the bouncy house, then that means you have to be less than or equal to 12. Or if you go to a ride at Cedar Point, some of them have signs that say you have to be at least 48 inches tall. Well, that means you have to be bigger than or equal to 48 inches. It can also be is no more than. So even though they have more or most in the words, that's really a less than or equal to. And then the at least is the opposite. The at least or the less than is really greater than or equal to. So make sure you keep those in mind, that at most and at least, which are very common to use, are actually the opposite of what they sound like. So now the lengths of the sides of a triangle are in the ratio 5 to 6 to 7. Describe the length of the longest side if the perimeter is not more than 54 centimeters. So again, we have a ratio question. Our variable is the unknown multiplier. The sides are actually 5x, 6x, and 7x. We have the perimeter is not more than 54, so the perimeter will be those sides added together. Not more than means less than or equal to 54. You combine like terms, divide both sides by 18, and you get x is less than or equal to 3. That question asked about the longest side. The longest side is 7 times that, 7x less than or equal to 21. The triangle's longest side is not more than 21 centimeters long. And finally, we have what are called compound inequalities. Compound inequalities are joined by and or they have two different signs within the same one. For a compound inequality with and, the solution has to be a solution for both of them. You can always, once you've solved, if you get a variable, combine them into an inequality like this with two less than signs. If you start off with one like this, you need to do the same thing to each part of it. So there are 3 parts. If I decide to add 2, I have to add 2 to each part. If I decide to divide by 3, I have to divide each part by 3. If I decide to multiply by a -2, I have to multiply each part by -2, and I have to switch both signs because I'm multiplying by a negative. Graphing is the same as we did before, only now we want to look at where the 2 overlap. And, as I said, can usually be joined into a single statement. Or means we want what's in this one and this one sort of put together. So it's either this one or that one. It's at least one of them. We want to combine the 2 regions together. We're going to solve each one separately, and then their solution is the union of the 2 sets, meaning we shade each part. Inequalities joined by or usually cannot be joined into a single statement, and they often give 2 separate parts. The and often give only one part. So now if we solve 2x minus 10 and 9x less than or equal to 18, this one we would divide both sides by 2 to get x is bigger than -5. This one says x is less than or equal to 18. If we divide by 9, we get x less than or equal to 2. Now both of those things have to be true. What numbers are both bigger than -5 and less than or equal to 2? Well, the only part that overlaps that is this part in between from -5 to 2, where the -5 is not included, but the 2 is. -5 less than x less than or equal to 2. For this one, again, we divide them both by 4. Here we're divide by 12. This is now an or. Or means I have less than or equal to 4. I have bigger than 12. I want both parts. I put them together. It's like putting them both down on the same number line. This one is really an and. So if you like, this is -6 is less than 2x minus 4. And 2x minus 4 is less than 12. But typically you just write it like this is 1. Then I want to get the variable by itself. So there's a -4. I'm going to add 4 to each part. So you would +4, +4, +4 to each part. -6 and 4 is -2. Here I would get 2x. 12 plus 4 is 16. Then I want to divide each part by 2. That would give me -1 is less than x is less than 8. The -1 is not included. The 8 is not included. And I want the part in between. By the way, when we have 2 numbers, before I had 1 before and 1 afterwards, if I have 2 numbers, I only need to put those 2 numbers in their correct order on the number line. Doesn't really matter how far apart they are when I do my graphs.